Now, okay, guys, welcome back to the channel. As you can see, we do have a very special guest. We have Kyle from Internet Computer or DFINITY. We're going to discuss DFINITY programming or Internet Computer programming SDKs, hello world, demos, all of that. So, Kyle, big welcome, and please tell us what you do and what your role is at DFINITY or Internet Computer. What should we call it, DFINITY or Internet Computer?
Well, thank you. Thank you for having me. There's sort of two separate things. The software is the internet computer. That's the thing that's out there. It's decentralized. It's running with the network nervous system and all of that. And I'm employed by the DFINITY Foundation, which is a nonprofit run out of Switzerland. And I'm in-house there working on the SDK team. So I maintain the JavaScript SDK, which has like an interface for talking to the internet computer from your front-end applications or say Node.js, as well as a few other NPM packages that we maintain for convenience sake.
Got it. And for people who are familiar with Ethereum development, which I think our viewers are, how would you describe the biggest difference between what DFINITY is doing and the Internet Computer's approach to smart contracts and blockchain tech versus Ethereum and Binance Chain and Polygon, what people are right now mostly using?
Yeah, there are some pretty hefty differences. The experience that you're going to have is going to be pretty familiar. We have nicely formatted APIs and are very friendly to JavaScript if that's the language that you like to approach Ethereum from. The tech is different in a couple key ways. The first one I would point to is that with the blockchain technology that we use on the internet computer, we're not distributing the entire ledger to every single node. Instead, we have what we call canisters, which represent a series of nodes that are able to communicate with what we have developed in-house as chain key technology, which allows us to have a limited amount of replication, which enables us to have web speed interactions with the blockchain. So you can create an update and write it within a couple seconds most of the time and get queries on the blockchain that were a couple millisecond response. And you can have a high level of confidence in those interactions, which enables us to do crazy things like running an entire website directly on the blockchain.
Mm-hmm. Interesting. And when we're looking at the node ecosystem, as far as I know, you need to have special hardware, correct? How does that work? And why can't I just download and run my own node?
Yeah. So there is the possibility that in future iterations that we'll be able to go for that. The biggest reason that we haven't yet is, one, there's a backlog of institutional third-party data centers who we're working through and getting them set up with their hardware. The second is that right now we're focusing on the general availability subnets and getting that up to the largest amount of capacity, and speed and performance are going to be the really biggest selling points. And with something like a distributed technology like this, the slowest node in the entire ecosystem determines how fast your total performance is. So we're really working with specialized hardware that's basically your canister is held in RAM that is able to persist state even if it loses power. So it's a newer technology. It's not generally available as consumer hardware.
Interesting.
And we're doing like terabytes of this kind of RAM.
Interesting. Well, as far as I know, the difference between RAM and normal SSD for persistent storage is that RAM has more expensive material. I don't exactly know which kind of physical material it is, but RAM is like super expensive. But you've basically created persistent storage with the same material that normally you do RAM with. Would that be correct?
Yeah, and I think that this tech is going to be growing in a pretty big way. So we'll be seeing more of it for the consumer market. But basically, the point is that we're starting with specialized hardware so that we can at least bootstrap the network and build up capacity in a way that people are going to be happy with. This is about really the user experience at the end of the day. We could grow through consumer hardware subnets, and that might be a thing that we're going to explore, but it's not like the top priority.
Got it. And so on Ethereum, you program your smart contracts in Solidity. Is basically that you add software to the blockchain, you add software to all of the different nodes, and then you can execute that software through transactions. And on DFINITY, on Intercomputer, as far as I know, you have your own programming language, and the idea is the same, that you can publish these blockchain applications that you call through transactions. Is that correct?
Well, the canisters themselves run and execute WASM, or WebAssembly. So any language that is statically typed can theoretically be transpiled into WebAssembly. We've got like a little bit of configuration that it'll take, but apart from that, like we've already got working C, Rust. I've seen a proof of concept for assembly script, and there are other canister development kits that people are working on. And we do a lot of work in Rust and are big fans of Rust programming at DFINITY.
But I did see an ad for I think Roboto. I don't remember exactly. Motoko. What is that?
Motoko is an in-house language, and it's basically designed from the ground up to take advantage of the aspects of the internet computer, as well. Basically, the like single actor model, the memory management. It's all designed around the ability to save state to stable memory, make it really easy to do upgrades. So you can actually change out the code and do an upgrade to your canister if it's in Motoko, as long as you've written it to stable memory and then deserialize it after an upgrade. As long as you don't change the schema beyond a place where it's broken, you can just automatically maintain everything across updates.
Interesting. And when you say that it is WASM, of course, it's good that you can use any language, but also it becomes problematic because if there is no official way to do something, there is no documentation, maybe community forum, questions, answers. You know, when people learn programming, they need to Google, they need to find an answer quickly. So that's why, you know, normally when I hear people say, oh, you can use any language, I don't necessarily see it as only good. I mean, it's good, but it's also bad because the community doesn't get united around one way to do things. And then it's difficult to get on board. So do you agree with that? Or how do you think about that?
I think that we actually have a really unique opportunity with WebAssembly as a target because we're finding that, well, first things first, our community is at forum.dfinity.org. And that'll give you a forum where developers can go ask questions. It's a managed community, and our engineers are active participants in it and helping people get unblocked. Secondly, we've found that some of our developers really like Motoko for certain parts of what they're coding, but then are really also able to take advantage of something like an existing Rust library. Maybe you want to do image transformations, or we've had someone run SQLite just natively on a canister because they already were able to take that compiled and do a little bit of massaging to get it working. So the nice thing is that you can take existing pre-built software from different languages and get it to execute on the internet computer. So over time, we'll see like standards emerge and people will find what works best for them. But we're just kind of supporting the ecosystem however it naturally grows.
Got it. So on Ethereum, if I want to communicate with the blockchain, I need to find the node, and if it's fully synced, it doesn't matter, you know, which node I speak to. It will. The idea is that I get the same result from all of them. But with canisters, and you say that it's subdivided, the network is subdivided. You don't have state everywhere. How does that work? If I'm to build something, let's say I don't want to build smart contract. I just want to build some kind of website that shows some stats, and I need information from different canisters. How would I build that, and how would I know where to query the different pieces of information?
Well, we could probably answer this question in real time if you want to get into the
let's go into
Hello World demo.
Exactly. So now we can see that on the screen.
Great. So I've got my terminal up here, and I have gone to DFINITY.org here. So obviously, I've been working here a while. I have the CDK installed, or the SDK. That's our little script. So we can do this here, dfx new hello. This is giving us a full stack application. So it's going to be creating 2 canisters for us. One is going to be a front-end canister, and the other is going to be our back-end canister.
So when you say front-end canister, back-end canister, is it, if we're thinking about, can we even think about how smart contracts are in Ethereum? Because here it seems like you upload the whole website, and that's a canister, right? And when you say back-end, do you mean like I upload a node server, like a canister also, or how do you mean?
Yeah, so the construct here, we have a asset canister, which is going to serve, like it's basically a purpose-built canister that knows how to respond to HTTP requests and resolve the files that we want to send back. And so it's configured so that we will pull from dist after we've like run npm run build, like you do with Webpack. And it'll just take all of those assets and put them up on the internet computer with the deploy command. On the other side,
but is that just static file, static hosting, or is it more like a Docker container that is getting deployed with some server logic? What can we compare this to?
It is, well, the literal thing that it is a WebAssembly file that we upload first, and then we run a post-upload script that will upload all of our files and save those in memory with sort of like a hash map of like the string or the key representing the file or the asset, and then a pointer to memory where that asset is held.
Got it. So it's
That's
like static
canister does.
It's like static hosting, but it's all in memory, right? Like you said, like right. It's index.html, all images. So this is assets, this is files. There's no like server logic that you send the request and some server logic is executed. Not yet, at least what we've seen here.
That's not what you're going to get with like the specific assets one. If you want to have server logic as well as asset delivery, then that's a little bit more custom, and you'll basically just be writing a traditional canister and adding asset logic to it as well.
Got it. So now we deployed the canister here for files, and we can see it with hello assets canister.
Yeah, and so here's just our logic here in Motoko. Very simple. It's going to have a greet method with a name of text, and it's going to respond to that callback. So let's get my DFX going. Cool. Now I'm going to just go DFX deploy. Since I didn't specify network IC, it's going to do this on my local replica. But it's basically just going to be the same command for putting it directly on the internet computer.
Mm-hmm. So we had the index.html as a resource, but now a main.mo, this Motoko file, where is that? This is the backend part of it, right? Because the index was an asset, and this is executable. So this is what we see now. And where do we specify it here? We specify it here in hello. Right. But so why is asset canister dependent on the hello canister? Because asset canister is just files. So why is there a dependency on the hello?
Great question. So because of the nature of Motoko, we are able to, in this hidden DFX, I'm letting you peek under the hood here. So in this directory, if we go to hello as the canister, it's going to create this hello.did file for us, which is the candid type declarations, very similar to protobufs. And it's telling us that we have a service here with greet as a function that takes text and returns text. And then that is giving us additionally some JavaScript declarations, which give us logics that we can just interface with that's already pre-generated. Yep. So we're going to take this canister ID. So we've created 2 canisters. It's going to finish this up in just a second here. And so now on localhost, after I ran dfx start, we're running a local version of the replica. And so this is like a little proxy server that we're giving you. And if I give a canister ID to it, I think it's not ready yet. Yeah, I'll wait until it finishes. But we'll use this proxy to make requests to our little local replica. All right, and so here we have localhost 8000. We've pointed our canister ID to our canister ID. And now we're getting back the response over the HTTP gateway that we're running locally. And all of these assets are being delivered directly from that asset canister after we uploaded them. So now this is the same index.html that we had from our file. Very straightforward. We've got relative asset imports. We've got our index.js as well. And this is the JavaScript logic that we're going to be running. So we import our actor. We set it up with an HTTP agent. This is important for like being multi-platform so that it's not just browser. Like if you need to add a custom fetch for Node or something, you configure that here, as well as identities. By default, you just have this anonymous identity, but any ED2551 something or other identity is going to be compatible. So we've had people do stuff with like MetaMask, and there's plenty of strategies that are very Ethereum friendly for integrating here. And then we create our actor, and that's going to have the secret files that we looked at under the hood so that we already know the interface. And that is how we have hello.greet as our interface, which is just going to be a nice little promise-based thing.
So,
and we set the page.
So from the HTML, you don't have to include any canister ID to that Motoko code, right? Because it's a dependency to this canister already. So you can just call it like this hello.greet because it's specified as dependency in that JSON file we looked at previously, right?
So we don't specify the canister ID here.
But we specify hello as dependency. Yeah, right there. So this means that this website can now get those functions without any import or anything else in the future. I mean, this is enough to connect the HTML site to the Motoko code. So we can call Motoko from HTML, from JavaScript like we do.
Yeah, with our build tooling, we sort of abstract that out. There is still a canister ID that is needed to know, which we're just generating based on the environment that you're running in. So if you're, depending on the network that you're deploying to, because it's local, we just give you this local one in the output. Once you've deployed to the internet computer, there will be a canisterids.json file that comes in your repo. And that will point to like the internet computer canister ID that you're going to deploy to.
Got it. And so if we go back to the Motoko code and look at it again, so what this does, it's just a function. Okay, so it doesn't store anything, but it's just that we execute some code, and this thing runs on internet computer, and it returns the greeting that we then display in the site.
Right. Nice. If we wanted to persist it, we could do something like a stable let saved equal like this. I'm not the crazy fluent for doing a live demo of Motoko, but it would look something like that.
But okay, so let's say that we have this site where I can enter my name, and we also have this Motoko canister where the names are actually persisted. So right now they're not, but let's say that they are. What if someone else wants to build their app and they want to read this info that I've collected in my app, which is a canister, which I guess is public information then, because if that's how it works on internet computer as on Ethereum, that everything you save on the blockchain is public. So is that possible? And is that easy to do if somebody wants to read data from one canister and they do their own canister?
Yeah, so it's different from Ethereum in that not everything is public. On the internet computer, you can have private information. It's more like an AWS kind of paradigm in that regard. So you can, anything that you choose to make public, you can have a very simple to use API that will look very similar to how we did this greet call here. You will just need to use the IDL, point to the specific canister ID that you know of, and then you'll be able to make calls to any canister that has an open API using one of the agents. So like we've got a JavaScript agent, we have a Rust agent, and there are also ways to make calls from within a canister, although that's like, we're still working on the ergonomics of that because we want that to be like really simple and a joy to use, and it's not quite yet, but it's totally possible.
Got it. Okay, so it's basically that you as a developer, you create some kind of interface that people can use. And in order for this to work, there needs to be standards. Like we have ERC20, ERC721, so that everyone develops their canisters in a way that other people know, like if it's a token or it's some kind of other common, maybe it's a wallet. So do you guys work with that as well? Are there any standards yet? Do you even want to have standards, or is it's just infrastructure and people do what they want, like AWS, where you just provide execution environment and hosting? So how do you think about that?
Yeah, there are discussions of standards, and they're probably going to be a little bit different. Like, people have done implementations of ERC20 already, but no one's really latched onto them per se, because there's a lot of additional logic that instead of like, with ERC20, you're saving the transaction to Ethereum, but then the logic itself is, off the blockchain. And there are some really powerful capabilities that people are excited about, where if you're building like an NFT or something, you can actually add logic directly into the contract itself, so that as it moves around, it can have these really exciting scriptable capabilities. So people are discussing how they want to do this, what they want to like gate versus what should be extensible from like some base point. I think we'll see something emerge, but this is very community driven. And the DFINITY Foundation is kind of agnostic around token standards on the internet computer. The one thing that we do have that we do encourage pretty strongly is using those candid declarations we saw. So this is a community dashboard that's being run. It's pretty great. And you can see all of these different canisters that are hosted on various subnets. This system subnet actually refers to the NNS. So just as an example, you can take a peek into what's available and publicly known about like the governance canister from the NNS, ledger accounts, and you can actually even see all of the canister methods publicly available generated from Candid, as well as the whole interface is self-documented, and you can even grab the Motoko JavaScript and TypeScript interfaces for it.
But what is the limit of a canister? Can I put like an EVM in a canister? Because I'm thinking how the current blockchain developers will use instant computer, and of course the community will grow as well, that people develop natively using Motoko or WebAssembly. But the lowest hanging fruit for everyone is to just copy their Ethereum apps and copy paste them into, like they do with Binance Chain or Polygon, just copy paste everywhere. And it's easy to get started and they get community on board. And then the community can bring the wallet adoption, which is the maybe number one thing that a blockchain needs, that people actually have wallets that work. But here it seems that you can use any wallet, like you say, with MetaMask, it's up to the developers. But basically, if I want, can I push an entire EVM like Geth into a canister? What is the limit of a canister?
So there are some limits. Like, for example, we have like a limited message size that we can like support, which is kind of due to a constraint of the actual WASM runtime. So if you have like a very large WebAssembly file, I don't think we have successfully done chunked uploads of WebAssembly. So we have like a constraint around the total size of the application that you upload. And that's been getting better, but I think that the cap is about 3 gigabytes right now. And then subsequent things that you have to like load into storage and so on. Another limit is that we don't allow push from canisters right now. So like if you wanted to have your canister on its own, like on a cron job or something, send out a push update to the external internet, that is not currently supported. So the way that you'd have to do that is to like poll and have like some sort of oracle that you're running on, for now, traditional servers to like actually send the push out.
Got it. So there has to be the community growth in instant computer. I think thinking what's important ahead for the project, where you have all of these interoperability solutions with ETH and mainly ETH. I mean, do you agree with that? Because we've seen a lot of blockchains try to grow, but the only ones that have succeeded in one way or another is if they have some way of taking talent and research and the community from ETH. How do you plan to grow community? Do you agree on that, by the way? Of course, there is Solana, there is Cardano. They will have KVM, so they're trying to get community from ETH. Solana, as far as I know, they don't have right now any connection to ETH. Elrond also don't have, EOS did not have, and they still don't have. So how do you think about that?
Yeah, ETH has done a really fantastic job in developing a community who's really passionate about it, and who've gotten really invested into the tech. And like, we definitely do want to court the Ethereum developer community. And the path forward on that could take a few different ways. I personally think that once we have the ability to make calls in some sort of standardized way to make updates on Ethereum, I think that the internet computer becomes a very appealing option for adding your scripting logic and doing your updates. And then maybe like it culminates in a transaction that's posted to the Ethereum blockchain. But otherwise, you can obviously, the lowest bar is you can host your website on the internet computer with a few steps and do a simple deploy. And then you're just good to go. You've got a decentralized thing. You're doing it on the blockchain as opposed to AWS. That's already like a step that any developer can take. And we're seeing a lot of existing Ethereum devs, that's going to be their first foray into the internet computer. But then, yeah, the interesting questions do come from how do smart contracts interoperate between the internet computer versus Ethereum, and what does that look like? And we're still seeing that evolve. So in a certain sense, I'm just as excited to see how that develops as you are.
Well, that's interesting what you said about that. If you're building a dapp on Ethereum, you can just use a canister for front end. That makes perfect sense because right now there's no good way of doing that. You could use IPFS, but then you need Brave or something that supports IPFS. And here you have basically no need for anything external. It's gonna work like a normal server. So that makes perfect sense. And what kind of domain will it be then? Because now we showed localhost, but if I upload to live network, will it be intercomputer domain, DFINITY? Where is the, at the end of this, there needs to be some HTTP server. So, and there needs to be some domain DNS connected to that. So how does that work?
Yeah, exactly. So right now, what that's going to look like is going to look something like, this is where we've got the JavaScript agent docs hosted. These are auto-generated out of like TS doc or whatever. And I just upload them so that we've got a reference for that. And so if we take a look at the URL here, it starts with the canister ID. The raw is actually optional. I can get into that in a second, but the top level domain is going to be ic0.app.
Got it. Okay, makes sense. So this gets me thinking what we could do with Moralis here, because we allow developers with one line to deploy their app, but we host it because there is no good way to host it in the centralized way. But with this, it's perfect because then with one line, they build their app and it's on Ethereum, but they can still host it on internet computer. Is there any fee with that, or is it just a command line command and that's it to deploy on this domain that you show?
Yeah. So was the question, is there any fee to deploy?
Yeah, exactly.
Yeah, so in order to go live on production, you're going to need a canister. And right now, the easiest way to create that is to go to nns.ic0.app. Also the same top level domain, but this is like one that we wrote a special domain for. This is our login solution. Oh no, everyone knows my login identity. It doesn't actually have to be secret. But this is using WebAuthn, and we've got a dedicated identity canister so that we've got this completely anonymous, passwordless, and email-less login system that is still secure and persisted on the chain. And that's giving me access to my balance. I don't have super much in here, but this is also the easiest way right now to create a canister is you can take ICP and use it to fund the creation of a new canister. Pick where you're deploying from. Let's say 5T cycles. And this is going to burn 1 trillion cycles, which is about like 65 cents. That's going to be my fee for creating a canister. And then it's going to put the rest of that balance as funds for the canister so it can continue operating.
Okay, so you have to continuously pay for a canister, right? To keep it online.
Right. So you pay the balance up front and it'll burn down. So you have to like top it off afterwards. And that's another thing that we're working on, for. So then the literal way that you would take this is I'm going to go back to here, DFX, identity, get wallet, I think. Or no, get principal is what I need. And so I'm adding my command line identity as a controller for this brand new canister that we created.
He's like the owner, right? Or what is that? Controller.
Yeah. So then I just copy the ID. And I can go into new file. Okay, and so now we've got canister_ids.json, and I'm adding in 2 canister IDs from the NNS DApp. And now that this is configured, I should be able to say dfx deploy flag no wallet because I added my principal directly. And network IC for the live internet computer. And just like you were saying, this is what it will take. Once you've done this, you now have canisters that will run on the internet computer until they run out of funds.
And when do they run out of funds? Is it computational cycles or network traffic? Because there are many components that could impact the load.
Totally, yeah. The largest fee that we have is the creation of a canister at this point. The second would be updates where you're adding additional size and configuring it for an expansion. Let's say you've had a lot of success and growth and you need more memory, that sort of thing. But the actual costs of running are very low, but I don't know exactly what they are for like ingress. I think we don't even charge for queries at this point. But that's subject to change by the NNS app.
Got it.
So just like that, we did our deployment to the internet computer. I'm going to go to the hello assets .ic0.app.
You forgot an I at the end of the IZ. It's CA.
I see, yeah.
Perfect.
There we go. Same application as before. And
perfect.
That is a real blockchain application.
Perfect. All right, Kyle. So now what we've done is that we went through what we can do with a canister, how to upload live, how to upload to local network, we briefly looked at how someone would add logic to their canister through Motoko. You can add logic through any language that can compile to WebAssembly. And then you can host your HTML, JavaScript, even if you don't want to use the logic in ICP, you can just upload the front end. So this is relevant for all blockchain developers that want to host something in a decentralized way, which is very popular because people want, censorship resistance and all of that for many use cases. But do you know how it works with internet computer then? Because at the end of the day, it is someone who has the domain name, and whenever people say that we want censorship resistance domains and hosting, does this apply, or you guys still have some kind of terms and conditions, I guess, because at the end of the day, somebody is hosting the domain, right? And somebody is responsible for all the subdomains there. So it would make sense that you have some kind of terms of service that people cannot upload something crazy here, because there are many use cases, that should not exist. I mean, not everything should be. There are some horrible things people can put online, So how do you reason about that?
Yeah. So backing up, first thing is the ic0.app domain is run by the DFINITY Foundation. Or it may be Internet Computer Association by now. We may have handed that over. I'm not 100% sure how that's shaking out. But the short of it is it's run by an affiliated group with the Internet Computer. And right now it is currently managed by secure devices on site at the data centers that we've partnered with. So that's how we're getting this distributed worldwide setup. So there's no CDN sitting between you. You are talking directly to an explicitly configured machine that's running the proxy. The way that you know for sure about the authenticity of the content is that if you are talking to ic0.app right here, the only way that you're going to be able to request your assets and be highly confident about them is they are all going to be delivered for you right now via a service worker, which is going to check a signed certificate that is signed with the root key of the NNS subnet And that is actually computationally verifiable, that even though it is a query, you can trust that it was signed by a majority of the nodes in the subnet. And you can reconstruct that for any individual asset that you request. You can bypass that with raw.ic0.app, which is important for like performance. You need to tell like robots.txt to look here because they won't be able to scrape the service worker, stuff like that. Anything else to discuss? Yeah, really just check out the DFINITY forum if you are interested in developing. You can @ me. I'm very active on there, as well as on Twitter. We also have a community at discover.one, which is another sort of Reddit-like forum. This is entirely running on the internet computer.
Nice.
So you can hop into here, get news about DFINITY, discuss. It's a really fun new platform, has all of those fun vibes as well. And yeah, I hope to see you try us out. And I'm here to help make your onboarding as smooth as it can be.
Perfect, guys. So you know where to go, forum.dfinity.org or .com? Forum.dfinity.org. Okay, forum.dfinity.org. So go there and try out some Hello World, and you can get active in the community. And Kyle, thanks a lot for being here. Go and follow Kyle on Twitter. You find the link in the description. And Kyle, it was a pleasure having you here on the show.
Pleasure joining you, Ivan.